All right, we are back with example 2, but first we got to go over some terminology. So let's get started. It says all the sides are congruent in an equilateral polygon. All the angles are congruent in the equal angular polygon. Okay, so that's really important. So all the sides are congruent. And you remember that from triangles, right? It was equilateral triangles when all the sides are different. I mean, all the sides are the same. And then all the angles are the same with an equal angular triangle. But now we're just calling it, when all the angles are congruent, we're calling that an equal angular polygon. All right? And this is a term that you're going to need to know, a regular polygon. And you're going to need to know what this means, is one, it's a polygon that is both equilateral and equal angular. So a regular polygon is both equilateral, it has all the same sides, and it has all the same angles. If a polygon is not regular, it's called irregular. Okay, so this is that classification. All right, so if a polygon is not regular, it is called irregular. Okay. Also, a polygon is concave if any part of a diagonal contains points in the exterior of a polygon. So what they're talking about there is, so here you see this, we have 1, 2, 3, 4 vertices, right? These two vertices right here and here are not consecutive, right? So theoretically they could form a diagonal. Now what happens is when we put a diagonal, one of the vertices, the diagonal is on the exterior of the figure and not on the interior. So when you have something like that on the diagonal on the exterior, it's called concave. The way I like to think is just if it's like sunken in a bit, you know what I mean? If the figure's sunken in, then it's called concave. But if no diagonals contain points in the exterior, then the polygon is convex. So this would be kind of like a regular thing. None of those vertices are sunken in like this one is sunken in. And all of the diagonals are inside the polygon. So this is a 1, 2, 3, 4-sided figure. So we could call this one a concave quadrilateral. And this is all of the diagonals are inside the polygon. So this would be a 1, 2, 3, 4. This would be a convex quadrilateral. All right, let's go ahead and start classifying some polygons. So what we're going to do is we're going to tell whether the polygon is regular or irregular, and then tell whether it's concave or convex. Okay, so remember, for it to be regular, all the angles have to be the same and all the sides have to be the same. It has to be equal angular and equilateral. So if you look here, these hash marks here mean that all the sides are the same, so this is an equilateral polygon. But if you look, is it equal angular? And no, these are the same, but these are different. So this is an irregular. It's not regular. It's equilateral polygon, but it's not equal angular. Okay, and you have to be both for regular. So it's irregular, and it would be concave or convex. There's nothing like caving in, so this would be convex. Irregular and convex. Okay, perfect. Okay, let's look at this next one, 2B. Okay, regular, irregular. So this one would have to be, for it to be regular, all the sides would have to be the same. They're clearly not, so this would definitely be irregular. And then we need the same angles. Now, if you look, it does look like we have these angles here. Oh, wait. No, it was just the sides are. We know it's irregular, right? But also we know the angles. These angles are the same, but there's also these angles here that are not the same. So this is not This is not equal angular. So we know it's irregular. Now we have to tell whether it's concave or convex. And if I take these two vertices right here that are not consecutive, I can draw a diagonal here, right? And that vertex is on the inside of the diagonal. So this would be, and it's, you can see it's like each of these sides are kind of like caving in. So this would be irregular concave. Okay, let's do the last one right here. 2C. What do you think? We got to tell if it's regular, irregular. So we need it to be equilateral and equal angular. So all the sides are the same, equilateral. All the angles are the same. Perfect. So this is a regular. And now just concave, convex. Is anything kind of caving in? And it's not. So it's regular and convex. Perfect. Now it is your turn to try, check it out, example 2A and 2B. Here's my friend the pause dragon. Remind you to pause your device. When you get done, press play and we'll talk about him. Okay, let's see how you did. We're going to tell whether it's irregular, irregular. So we're looking at this figure. It's got to be equilateral and equal angular. All the sides are the same. All the angles are the same. So we know it's regular. Perfect. And then we want to know, is it concave or convex? So it doesn't look like anything's caving in. So this would be regular and convex. So if you got that right, great job. Okay, let's look at this one. Regular, irregular. What'd you guys put? This would be irregular because all the sides aren't the same and all the angles aren't the same. So irregular. And concave or convex? This side, these two sides are kind of like caving in, so this is definitely concave. So if you got that right, awesome, awesome. And I'll see you in a little bit for example 3.